Let's look at part two. Hopefully you got that labeling down. That's the fundamental thing to start with, is knowing what to call the sides. Let's see here. In this one, example one, we're going to find the sine of angle A, cosine of A, and tangent of A, and then the sine of angle B, cosine of B, and tangent of angle B. So we have them labeled right now with respect to angle A. If I marked angle A right here, then yeah, this is the hypotenuse, of course, for either angle. But then opposite angle A is this side right here. That's why it's labeled opposite, and this would be adjacent. So then now we can look at these things and set up the sine as the length of the side opposite over the hypotenuse. So opposite angle A is 5, and the hypotenuse is 13. And this doesn't reduce. Sometimes they divide it out and give you the decimal value, but we'll just leave it like that. So that's how it's done. Once you label them, then you can look at your definition of sine, cosine, and just put the right sides on top and bottom. So the cosine of angle A, they're still labeled with respect to angle A, so adjacent is 12, hypotenuse is still 13 there, 12 over 13. And then the tangent is opposite over adjacent, so the opposite side is 5. The adjacent side is 12, 5 over 12. Now with respect to angle B, we have to switch this opposite and adjacent side. So this becomes the adjacent side, and this becomes the opposite side, because we're talking about angle B. Opposite angle B is this side. This is always the hypotenuse, and so this becomes adjacent. So now we can look at our definition. So sine is opposite over hypotenuse, so opposite now is 12, because we're talking about angle B. Hypotenuse is still 13. 12 over 13. Cosine of angle B would be adjacent, which is 5 over 13. And then the tangent, the opposite over adjacent. And that's simple. Okay, it's just knowing how to label them first. And then looking at your definitions. Look at your notes, that page over there with the definitions back here. Always keep this handy. Okay. Look at example 2 here. It says use trigonometric tables to evaluate expressions involving trig ratios. Find each value using a trig table. Well, we're going to actually use the calculator. And to use the calculator, the number one thing is you have to be in degrees, not this other measure called radians. So you can see I've got the calculator in the screen. You turn it on, press the mode button, and degrees should be highlighted. A lot of times the radians will be highlighted in the default mode. So you would have to come down over here and get in degrees and hit the enter. So make sure it's highlighted. Okay. So mine's in degrees now. And it's as simple as putting it into your calculator. The cosine of 41 degrees, since we're in degrees. So cosine's right here, COS. And then put in the 41. You can close those parentheses afterward. So the cosine of 41 degrees. Now, normally we do 4 decimal places. That's how it used to be in the old tables. So I see 0.7547, and the next number is a 0, so I'll leave this as the 7 at the end. It rounds to 0.7547. Okay, so that's all you're doing with those. Here's the tangent of 23 degrees. Tangent is right next to it, so hit the tan button. And then 23. It's simple as that. But the number one thing here is make sure you're in degrees. Okay? Once you put it in degrees, it'll stay that way. But when you come in the next day and you're going to do some problems, make sure it's in degrees when you're doing trig problems. So this one rounds to 0.4245, since that next number is a 7 after the 4. We'll round that up to 5. Okay? You can double check these last two, plug them into your calculator, and there's those two. No big deal. For example 2, just plug them in your calculator. Make sure you're in degrees. Now we get to the real problems here. Example 4. I skipped example 3. We're going to go to those type of problems a little later, some other time. Right now, here's what we want to learn how to do. Find missing sides by setting up trig equations. So we're going to find x here. A trig equation has one of the trig names here, where I got trig function. Then it has an angle measure, or an angle. And then it equals the ratio, the fraction of sides. You know, like in sine, it was opposite over hypotenuse. So here's how we do this. The first step is that labeling process. Here's our angle. Here's a acute angle we know. And so I'll mark it. Now we're going to label them with respect to this 27-degree angle here. So of course this is the hypotenuse. I don't know if they had that. It doesn't look like they had the right angle. They should have had that in there. So here's our hypotenuse. Opposite this 27 degrees is over here, the x side. That leaves our last side as the adjacent. Now which two sides do we use? Well, we're going to solve for x. We want to know x, so we got to use this side. And we got to use one we know. So the two sides we're going to use in this trig equation are hypotenuse and opposite. So if you go back to that very first page of notes, which trig function, which one of the three, and only one of them uses these two sides? And that is correct. That would be the sine function. The sine uses opposite and hypotenuse. So that's how you tell which trig function you're going to use. We're going to use the sine. And now you're going to take the sine of an angle. An angle measure goes here, and it's the angle we're using here that we marked everything with, the 27 degrees. The sine of 27 degrees equals, you look at your notes, what is sine? It is opposite on top and hypotenuse on the bottom. So the opposite side is x, or opposite, and the hypotenuse is on the bottom. That's 12 in this problem. So here it is. Here's the equation set up. Now we'll show you how easy it is to solve it. Where it says equation, that's what they wanted, was this original equation right here. The sine of 27 degrees equals x over 12. And again, it starts by what? Looking at the angle you got and then labeling the sides with respect to this angle. Hypotenuse, opposite that angle is this side, adjacent. And then looking at what we're solving for x, we need this side, and we need one we know, because adjacent we don't know anything about. So these two make the sine function, and then opposite over hypotenuse. Now how to solve this? We always take and turn it into what's called a proportion. This is a fraction, so I'm going to turn this into a fraction by just putting it over 1. And then we cross multiply. So 1 times x is just x. That's one of the cross products. Now this cross product equals the other one. So the other cross product is 12 times the sine of 27 degrees. We saw that, this is just represents some little tiny number, and we'll get it in a minute from the calculator. But we always put that number first times the trig function. All right, so the 12 goes out in front. Written like this, it means 12 times the sine of 27 degrees. You don't have to use a time sign. You don't have to use parentheses. In mathematics, we know that when it's written out in front of this sine function, it means multiply it times it. And your calculator knows it also. So all you have to do is pick up your calculator now. We've got it. I've still got mine in degrees. And punch in x is already solved for. It's by itself here. X equals 12 times the sine of 27 degrees. So I put in 12. And then the sine function right here in the middle here of 27. And close up parentheses. And rounded to the nearest tenth would be 5.4. The next number is a 4, so we're not going to round it up to 5.5. We're going to leave it at 5.4 approximately. Okay, that's all there is to it. You'll see later it gets a little different when x is on the bottom of the fraction. We have to do a little bit more. But when it's on top, it's pretty easy. Okay. Label the sides, figure out which two you're going to use, which trig function uses that. Set it up. Make it a proportion by putting 1 on the bottom there. Cross multiply. Boom, it's done. Put it in the calculator. Let's try some more. Alright, here we go. Let's see, here's our 21 degree or 69. I think I did it with respect to the 21. You could do it with respect to either one. But let's see, if I mark this one right here, then opposite would be over here. The x side would be opposite. I'm going to just put OPP for opposite. This 9 side right here would be the hypotenuse. There it is across from there. So this one's adjacent. I'll put ADJ. Alright, now they're labeled. Which two we're going to use? Well, we have to use the x side because that's what we want to solve for. And we have to use the side we know the length on. That's this hypotenuse. So let's see which one uses opposite and hypotenuse. That would be the sine function. So let's see. The sine of what? The angle we marked at the beginning, not the 69. I marked the 21, and with respect to those, I put opposite and adjacent here. So the sine of 21 degrees equals the side opposite, which is x, over the hypotenuse, which is 9. Turn it into a proportion. Put this over 1 and cross multiply. This bottom times this top. It's nice and easy when x is on top. 1 times x is x. And then remember, we're multiplying 9 times the sine of 21. So the 9 goes first, and then the sine of 21. And you plug it into your calculator just like that. And we are already solved. It's ready to just plug in the calculator. You double check me. I've got about 3.2 for x. So again, our equation was this, sine of 21 equals x over 9. And we got approximately 3.2. I think I'll go keep going and get a few more of these examples done. Here's a quick check. I'm going to let you try that one. And go ahead and put your answer into the quick checks coming up a little later. Nah, go ahead and do it. You need some more examples. So I'll give them to you. You might want to pause this video and try it on your own. I think I'll buzz through this pretty quick though. Alright, if you pause and try and set it up on your own and then check it, that'll do you the most good. Okay, so try pausing it now and then I'll do it. You can check your answer after you're done trying it. Alright, hopefully you paused it and you've got an answer. Let's see. Again, yours could be different because it depends which angle you pick here, since they're both given to you. I forget which one I picked. I'm gonna guess it was the 37. With respect to that, let me take a little peek here, see what I got. Oh, yeah, cosine. Yeah, I think that's what I did. Because with respect to this, let's see, of course, this side is the hypotenuse, HYP. Oops, I can't write too good. Opposite this angle would be over here. Here's my opposite side. It's supposed to be an O. So this would be the adjacent, ADJ. So let's see which two sides am I going to use. Adjacent because it's got my x. Then I got to use one I know. I know the hypotenuse here. I don't know the side opposite. So which trig function uses these two sides, adjacent and hypotenuse? That would be cosine. So we got cosine of the angle, which is 37. I'm using 37. Everything's marked according to it. Equals the side adjacent on top, which is x. On the bottom, the hypotenuse. So again, we're going to set it up as a proportion, put it over 1, and cross multiply. 1 times x is x. And how do we put that other side? 13 times the cosine of 37. The 13 goes first. You don't want it here at the end next to the 37. You're going to get all kinds of mistakes because you're going to multiply that times 37 and take the cosine of some big number. Alright, so now it's solved. X is by itself. We're just going to plug that into the calculator. You can check me. You should practice this with your calculator. Make sure you're getting the same things and you understand the rounding. I round to the nearest tenth. I've got 10.4. So the equation was cosine of 37 equals x over 13. That's what we started with. And I got x equals 10.4. Now, someone that marked the other angle and did the sides label, with respect to this 53-degree angle, would get a different equation here, and that'd be interesting to see if anybody got them. But if they did everything right, they'd still get the same answer. Okay? Take a look at, I believe we're coming up on the last few examples here. This time we've got x and y. So I start off label the sides. So I pick the angle I'm going to use. I'm going to use this one. I could figure out this one, but no use doing extra work. With respect to this 54-degree angle, of course, our hypotenuse is right here. Opposite this angle is over here. This side is the opposite. OPP for opposite. That makes this side, the 8 side, adjacent. So I'm going to start with an equation to solve for x. So I'll use this hypotenuse side as my x. And the adjacent side I know is 8. So hypotenuse and adjacent. Which one uses that? That's right, that would be cosine. So cosine of the angle I marked, 54 degrees. What's on top is the adjacent side, which is 8 in this problem. On the bottom is the hypotenuse, which is x. So here we'll see something a little different. It's the first time we get x on the bottom. Okay, what happens? Well, let's turn it into a proportion, put it over 1. Now we're not multiplying the 1 times the x, we're multiplying the 1 times the 8. Well, 1 times 8 is 8. I put it on this side. And then now we've got x times the cosine of 54. Just like when we're multiplying a number times a trig function, that number goes in front, so we're going to put the x in front. So we write it as x times the cosine of 54. Okay, so this is multiplication. We got some number x times this little number cosine of 54, which is like a decimal number. So to undo this, we're going to divide by this cosine number, cosine of 54. So all this does is this cancels out to this right here and gives us x all by itself, just what we want. How do we get what x equals? Well, we can take 8 divided by the cosine of 54. So you ought to practice that with your calculator. Okay, I'm still in degrees, so I take 8 divided by the cosine of 54 degrees. Close that parentheses on cosine. And there I get about 13.6. Rounded to the nearest tenth here. Okay, so that's all that was different there. What happened? We didn't, we weren't taking 1 times x now since x wasn't on the top. So we got x times some little number here, the cosine of 54. We just divide by it, both sides. This cancels out, and we just put the other side into the calculator and get our answer. So we'll go ahead and solve for y now. For y is the side opposite over here. And I'll go ahead and continue. I could use the x side, but it's only an approximation, so I'll take this exact number right here, 8. I'm going to use opposite and adjacent. Which trig function uses those two? Look it up on your notes. The only one that uses opposite and adjacent is tangent. So we got tangent of the angle we marked, 54. And tangent is the opposite side, which is y in this problem, over the adjacent side, which is 8. And we can set it up as a proportion. This time our variable is on top in this equation, so when we multiply 1 times y, we get the y over there. This is the easy one. Equals the other cross product, 8 times the tangent of 54. So that's exactly how you put it into the calculator. Try it. Put it in there, check my answer, see if it rounds to 11.0. So there's our 2 equations. The first one for x was this cosine equation. Cosine 54 equals 8 over x. And we got x was approximately 13.6. The other equation was tangent of 54 equals y over 8. And y came out to approximately 11.0. All right, one last one just to give you a little more extra notes here. So here we go. We'll go quickly. You pause it if you need to. You might listen to it first and then go back and rewind it. So here's my angle. So here's the hypotenuse still. Opposite this angle is this side. So here's our opposite side. So here's adjacent, ADJ. I'll solve for x first, so I'm going to have to, when I'm solving for x, I'm going to use the adjacent and opposite. Take a look. Which one uses that? Adjacent and opposite is tangent. Tangent of the angle, which is 25 degrees, equals the side opposite on top, which is 10, over the side adjacent, which is our x. So here we get that little bit of tougher one with the x on the bottom, the variable on the bottom. So 1 times 10, this cross product is 10. Then x times the tangent of 25, we write like that, x first. So then all we have to do is divide by this tangent of 25. That's just a number. Okay, it cancels out. We get x equals 10 divided by the tangent of 25 degrees. And check that out with your calculator. Should get about 21.4. So you can write the equation down and the x down. Now we'll go solve for y. For y, we've got this hypotenuse side, and I'm going to use this opposite, exactly 10. So hypotenuse and opposite, that is sine. Sine of what? The angle we marked, 25 degrees, equals the side opposite goes on top, that's a 10. And hypotenuse on the bottom, that's the y. So again, we got the fun one where we got to do a little extra work. Cross multiply, 1 times 10, this cross product is 10. And then we have y times the sine of 25 degrees. So we divide by the sine of 25 to get rid of it on this side and get y by itself. All it does is cancel out over here. And our answer, y equals 10 divided by the sine of 25 degrees. Check it out with your calculator. I got approximately 23.6 rounded to the first decimal, the nearest tenth. So we write our equation and our y. Alright, so now give it a try on the practice problems. Work them out on paper and turn them into our teacher, our substitute teacher. Have a great day. I'll see you in a day or two.